Very good morning, my dear students. Let us start today's session. We were discussing a chapter called Motion in a Straight Line. In motion in a straight line, let us start kinematic equations, basics. Then we will move into the another topic. Just the basics we are going to discuss now. Imagine there is a body starting from point A, moving here to the point B. The whole journey, the body is moving with an acceleration which is called a uniform acceleration. What is it called? Uniform acceleration. If a body is moving with uniform acceleration, then only the kinematic equations are valid. Otherwise, they are invalid. Remember, to use the kinematic equations, the one and only condition is the body must be moving with uniform acceleration. Uniform acceleration means constant acceleration. Understand? Or uniform deceleration or constant deceleration. Understand? So the body must be moving with uniform acceleration or deceleration. Now, it is starting with initial velocity u. So where u is initial velocity. What we have considered, body is moving with uniform acceleration means the speed must be increased. Uniform acceleration, speed must be increased. So the speed is increasing. At the point B, the body has attained a velocity v. So that's called the final velocity. Definitely, by starting with some initial velocity to reach this final velocity, the body will take some time t. Understand? So that is t. Time taken to move from point A to point B. When it is taken some time, the body definitely will take some displacement even from the initial point to the final point, right? So that S is called a displacement. Now the point of kinematic equation comes into the place. What these kinematic equations are also called as equations of motion. These kinematic equations are also called as equations of motion. So what these equations of motion or kinematic equations do? So they give the relationship among all these 5 physical quantities, right? So the kinematic equations will give the relation among all these 5 physical quantities. Uniform acceleration, initial velocity, final velocity, time and displacement. How many kinematic equations we have? We have 3 kinematic equations majorly, right? So let us write what are those. So the first kinematic equation v is equal to u plus at. The second one, s is equal to ut plus half at square. The third one is v square minus u square is equal to 2as. Right? So from the third kinematic equation, there was an application s suffix n is equal to u plus a into n minus half. What about this fourth equation, kinematic equation? We'll discuss later. Then another equation also comes under kinematic equation. Listen to me carefully. We know distance is equal to speed into time. Understand? So let's see here. We know the distance is equal to speed into time. If a body is moving with uniform acceleration, right? If a body is moving with uniform acceleration, You can write another equation under the kinematic equation. Listen to me carefully. So the displacement is equal to average velocity into time, where average velocity in this case will be initial velocity plus final velocity by 2 into time taken. Remember these 5 equations. V is equal to u plus at, s is equal to ut plus half at square, v square minus u square is equal to 2as, Sn is equal to u plus a into n minus half. Displacement is equal to average velocity into time. In this case, as the body is moving with a uniform acceleration, so the average velocity is v plus u by 2 into t. Alright, clear? And you know how the questions will be asked on this, and that questions part will come to later. We'll discuss later. But the basic questions will be asked in today's assignment. Basic questions means what? So the time value they give. Let's take an example of v is equal to u plus at. Carefully see. The time they give, final velocity value they will give, and initial velocity value also they will give. Can you find the acceleration? Definitely you can find. Right? These are the 8th standard, 7th standard numericals. You got the point, my dear students? So this kind of basic problems will be given to you, right? How? Look at this. So there is a body which is starting from rest. Initial velocity of the body is 0. And after some time of 5 seconds, the body has attained a velocity of 10 meters per second, right? Now the question is, what is the uniform acceleration produced here? And from this first equation of motion, we have A is equal to V minus U by T. What is acceleration? Which is equal to final velocity is 10 minus initial velocity is 0 by T is 5 seconds. So 10 by 5 is 2 meter per second square. SI unit of acceleration is meter per second square. Understand? So like these basic questions will be asked, my dear students. So here the body is moving with 2 meter per second square. Now the question is, by using this data, let us find what is the distance traveled from here to here. So the distance traveled, S is equal to ut plus half at square. So S is equal to, what is S? Displacement or distance traveled. As the body is moving in a straight line without turning back, the distance and displacement taken by the body is same. Isn't it? As the body is moving in a straight line without turning back, the distance and displacement taken by the body is same. That's what I am saying, distance or displacement. S is equal to ut plus half at square, where u into t, initial velocity of the body is 0 they gave. So they will not give initial velocity of the body is 0. They'll give the body is starting from rest. Starting from the rest means the body is at 0 initial velocity. So 0 plus half acceleration, just now we have found 2 into t square. What is the total time taken here? T square. So it is 5 square, it's 25. So 2 gets cancelled. So S is equal to displacement taken by the body is 25 meters. Right? Clear? So the same you can also find by using the third equation, v square minus u square is equal to 2as. And let's use this equation, v square minus u square is equal to 2as. From here, S is equal to v square minus u square by 2a, and this v square is 25 minus 0 square is 0 by 2 into acceleration is what? So this is the acceleration, which is 2. Alright. Now, sorry, v square is not 25, so v square is 100, right? 100. So now S is equal to 100 by 4, you got 25 meter again. You see these two values are same. So according to the data given, you should use the formula. So most of the students have doubt. I've seen 90% of the students have doubt which formula to be used in which numerical. come out of this doubt, you must go through the basic videos of kinematic equations. So many basic problems solved like this, basic problems. And some advanced problems also I have solved during that basics class. You must go through that. Then you'll understand the complete kinematic equations clearly. Before going to the next topic, because kinematic equations we are going to deal clearly after a small topic called graphs, also called graphical representation, graphical representation of motion. This is the topic we need to do now. After this, we'll come back to the kinematic equations and we'll discuss in detail the numericals, everything. Now, so before going into the graphical representation of motion, I just wanted to tell you about this application. Carefully see. There is a small difference between the second equation of motion and this equation of motion. The second equation of motion is S is equal to ut plus half at square. So let's talk about the second equation of motion here. A body is starting from point A and reach to the point B. In how much time? Imagine in 4 seconds. So that means it is covered a distance S1 in first second, right? In first second. It is covered a distance S2 in second second, a distance S3 in third second, a distance S4 in fourth seconds. Did you understand, my dear students? Total distance travelled in 4 seconds will be S. S is equal to S1 plus S2 plus S3 plus S4, and that S is ut plus half at square. Okay. Now, what is this Sn? In a particular second, this n is in a particular second, nth second, that may be in third second. What is the distance travelled by the body in a third second? Look at here. So just now I told you, in third second, the body is covered the displacement of this much. So find this, you need to use this formula. Understand? So what is this n value now? Third second. In a particular second, the distance or displacement taken by the body is called Sn. S3 is equal to u plus a into 3 minus half. If it is S4, u plus a into 4 minus half. Got it? Clear? Total distance taken by a body in a particular time can be found by using the second equation of motion. In a particular second, the distance travelled by a body to be calculated by using this formula. Sn is equal to u plus a into n minus half. Alright, my dear students. Let's come back to a graphical representation of motion. And this graphical representation of motion also we had discussed in detail, right? But still, a lot more to be discussed in this area. And let's recap the graphs and graphical representation of motion. Any graph will have x-axis and y-axis. Look at here, x-axis and y-axis. This x-axis is represented with some physical quantity and y-axis will be represented with some other physical quantity. Understand? X-axis will be represented with one physical quantity, y-axis will be represented with another physical quantity. This is called the coordinates. This is called what? Coordinates, and this is the origin. This is graph. Now graph line is what? Look at here. The graph line may be like this. 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 Look at here. So many graph lines. So the graph line may be like this. Not all together. Okay. So for individual body, what is the topic? Graphical representation of motion. For individual body, the representation of motion may be in any form of graph line, like this, like this, like this, like this. Okay. So the graph line may be like this. So the graph line maybe like this. The graph line may be like this. These are called graph lines. After identifying what is along x-axis, what is the quantity along y-axis, after understanding the graph line, now it comes the interpretation of the graph. What is that? Interpretation of the graph. From the interpretation of the graph, you should understand the graphical representation of motion. Understand? Clear, my dear students? We had already discussed about slope of a graph. Slope of a graph. It's so simple. Look at a graph here. This is x-axis, one physical quantity, y-axis is represented with another physical quantity, and I have a graph like this. Graph line. How to find the slope of this graph? This is origin, and imagine this is y dash and a value, right? For example, if y is taken the displacement, so the y dash may be some 10 meters, right, or 5 meters. So along x-axis, this is the point represented with x dash. Okay. X dash, if along x-axis, if you take time, the x dash may be some 5 seconds, 6 seconds, something like that. Now, how to find the slope? It's so simple. Carefully see. From the x-axis, you need to measure the angle in anti-clockwise direction. Look at here. From the x-axis, you need to measure the angle in anti-clockwise direction. So this angle is called theta here. This theta, if you find tan theta for this, that's called the slope. Tan theta for this angle, T. There is a triangle found here. You can carefully see. There is a triangle. Tan theta is opposite side of this triangle. What is opposite side of this triangle? Opposite side means the y-axis. This is y dash, this interval I am talking about. Y dash minus 0. So this is y dash minus 0 divided by. For this triangle, this is called the base. Right? Opposite side by adjacent side. Right? Height by base. What is base here? Base is along x-axis, and this is the x dash and this is 0. This interval we need now. X dash minus 0. This is called the slope. Alright, my dear students? This is called slope. This is called average slope. What is it called? Average slope. Average slope. If you want an instantaneous slope, my dear students, instantaneous slope, and that is called your dy by dx. That's a differentiation. Instantaneous slope at any point, if you want the instantaneous slope, so that's called dy by dx. You know, y is a function of x. In dy by dx, y is a function of x, my dear children. This is the basics about the slope, right? Any point you find tan theta, that's called the slope. Now, so many interesting points related to the slope we'll discuss now. Then we will move to the position time graph, a velocity time graph, and acceleration time graph. Let's look at the slope concept. I have told you from the x-axis in anti-clockwise direction to the graph line, if you find the angle, that's called the slope. At any point you can find the slope. Look at here, at this point if you want to find the slope, carefully see. Imagine drawing a x-axis here and find the angle. So this is the graph representing the constant slope. Slope at this point theta, slope at this point theta is same. At any other point if you want to find, so the theta will be the same, so that's called the constant slope concept, right? So whenever you find this kind of graph that is equal to constant slope, listen to me, this is the easiest way of learning a graphical representation of motion, my dear students. So this is the kind of graph represents a constant slope. This is x-axis and y-axis. Alright, my dear students. So what is this graph represents? A constant slope. Okay. Constant slope. And this constant slope is positive because whenever your slope value, the theta, if theta values are less than 90 degrees, you find a positive slope, and your theta values are greater than 90 degrees, you find a negative slope. So this you might have discussed in your basic mathematics, right? Here, what is the angle of theta? This theta is less than 90 or greater than 90? This theta is lesser than 90, so that means the positive slope this graph will have, right? Now, this is constant slope, which is positive. Now, x-axis and y-axis, and let me see, my graph is like this. What I have told you, at any point if you want to find the slope, let me say the slope at this point. See, look at the angle here. From the x-axis, in anti-clockwise direction, I found the angle. So this angle is greater than 90 degrees, and this is a negative slope. What is this? Negative slope, but it is constant. Yes or no? Negative slope, but it is constant. How it is constant? Because at any point if you find the slope, you can see the slope you get, theta is greater than 90 only. This is called a negative slope. But wherever if you are finding the slope, right, wherever if you find the slope, that will be tan theta is y-axis interval by x-axis interval only. Okay, clear? Now, one more, let's see. One more, and this is the graph. Carefully see, this is the graph I have. This is the graph. So let me take 2 points here. This is point A and this is point B. In the curved line, this is a straight line, right? In the curved line, if you want to find the slope at point A and point B, carefully see. At point A, you need to draw a tangent at point A, and for this tangent you can find the slope from the x-axis in anti-clockwise direction, right? So this is theta 1. At point B also, we need to draw the tangent line. Look at here. At point B, the tangent line I have drawn. So the angle is theta 2. Which is more? So theta 2 is more than theta 1, right? So definitely, at point B, the slope is more. I'll redraw the diagram with a bigger way so that you will understand far better. So this is x-axis and this is y-axis, and this is the origin. I have got my graph in this way. The question is, so there is a point A. At point A, I am drawing a tangent line. Look at here, this is the tangent. So for this tangent, you can find the slope. This is what the slope I measured, which is theta 1. At point B, I can draw the slope. If I want to find the slope, I need to draw a tangent like this at point B. See the angle here. At point B, the angle is theta 2. Which angle is more? So this is theta 1 and this is theta 2. Which angle is more? So 100% theta 2 is greater than theta 1. That means this slope is increasing. So this slope is more than this. Right? And one more. Listen. There is a point C is here. At point C, the slope is less than this. At point X or at point M, look at here, the slope is keep on increasing. So this is the graph represents increase in the slope. What is that? Increase in slope. So this is the graph represents increase in slope. Constant slope positive, constant slope negative. So here increasing in the slope. So increase in the slope. So here increase in the slope. Whatever, it's not greater than 90 degrees. So it is also positive. Same way decrease in the slope is also possible. So this is the graph represents decrease in the slope, my dear students. This is x-axis and this is y-axis. So decrease in slope. Right? Now look at this x y. See this. What is the slope of this graph here? What is the slope of this graph here? The slope of this graph is 0 because at this point, if you want to find the slope, Let us draw a tangent here. So the tangent is not at all making any angle with x-axis, because x-axis and this tangent are parallel, and x-axis, this graph line, are parallel as, let me write here, as x-axis and the graph line are parallel, then the slope is 0 degrees, right? When the slope is 0, right? Remember, this is called a zero slope. Carefully see. Increasing in the slope, decreasing in the slope, zero slope, positive slope, negative slope, all the things we had discussed. Now, if you really understand this part, you are exactly and actually eligible to go further part of graphical representation of motion, my dear children. Now, look at here. Again, come back to the concept of slope. Let's look at this example. There is x-axis and y-axis here. One body graph is mentioned here, so this is A. There is a body A whose graph is mentioned in this, whose graph line is mentioned like this, according to its own motion. So there is a graph line B. So this is for a body B related to its own motion. The graph line is mentioned here. Whose slope is more? Slope of graph A is theta A, and slope of graph B is theta B. Whose slope is more? Theta B. B's slope is more than A. How to find this theta A? Right? So sometimes a question can be asked, what is the ratio of their slopes? So ratio of their slopes will be tan theta A to the tan theta B. Theta means some values they give, right? Imagine the theta A must be a 30 degree, theta B must be can be a 60 degree, right? So you can find tan 30 by tan 60 value. So that's called the ratio of their slopes. Understand? Clear? So ratio of their slopes you can find in this way, just by dividing their tan values. Okay, my dear children? Clear? Now, graphs. Position time graph, velocity time graph, acceleration time graph. So these are the three graphs we are going to discuss in first PUC topics. All these except this kind of things we have discussed in the basics. That's the difference here. So this we have moved in detail about the graphs. This is three kind of graphical representation of motion we are going to do. In this position time graph, there will be 5 to 6 different types of graph based on this. No other graph you get other than this. Your graph line or graph representation may be like this, or like this, like this, like this, like this, or like this. How many are there? 1, 2, 3, 4, 5. Because these two are same. Alright? Because these two are same. So almost 5. So in position time graph you have 5 different types of graphs, and velocity time 5 different types, and acceleration time 5 different types of graphs you will get. Listen. At any point the position of the graph can be identified, the position of the body can be identified by using position time graph. First point is common in all the graphs. At any point, if you want velocity, instantaneous velocity, you can find from the velocity time graph. The instantaneous acceleration of a body can be calculated by using acceleration time graph. The first point is same. Let me tell you once again. Instantaneous position of the particle, instantaneous velocity of the particle, instantaneous acceleration of the particle can be identified from these graphs. First point. And the second points are very, very important here. In position time graph, look at here. In position time graph, carefully see my dear children, the slope will gives you displacement or distance. See, I am writing displacement here because when a body is moving in a straight line without turning back, the distance and displacements are same. Okay, look at here. The slope of position time graph gives you what? Displacement. In velocity time graph also, let us discuss the similar way. In velocity time graph, the slope will gives you acceleration. Remember, listen. The slope of velocity time graph gives you acceleration. The slope of position time graph gives you displacement. Alright, my dear students. Now, acceleration time graph. So, before moving to the acceleration time graph, one more point you need to understand. The area under the graph, look at here, the area under velocity time graph gives you displacement. Area under velocity time graph gives you what? Displacement. What is area under the graph? Let's discuss about this. Right? What is area under the graph? For example, this is a graph you have of constant slope. Imagine this is the graph line, right? This is the graph line. So, and this is the point along x-axis and this is the point along y-axis. Under the graph line, there is some area. Under the graph line, see, this is area. This area you can find by using area of a triangle formula. Half into base. See, this base will have some value, right? Because x-axis is represented with some physical quantity. Let me say this is represented with a physical quantity called time. And this will have some time. Imagine that is 5 seconds. Y-axis is represented with some physical quantity. Let's imagine that physical quantity is some velocity, right? So now here that velocity value may be some 2 meters per second. The area under the graph is how much? Half into a base into height. See, there is some value here. It's a 5 meters. There is some value. So area under this graph will give some physical quantity that's called displacement. Area under velocity time graph gives you displacement, and slope of velocity time graph gives you acceleration, and slope of position time graph gives you displacement. My dear children, listen to this carefully because based on this only our next topics depends. Last, acceleration. Here. The slope of acceleration time graph gives you change in velocity. What is that? Change in velocity, my dear students. The slope of acceleration time graph gives you change in velocity. Clear? Alright. This is the very, very, very important part where we'll discuss in the next class related to the complete graphs. Right? So, my sincere request to you is that go to the basics of kinematic equations and graphical representation of motion. Go to the basics of kinematic equation and graphical representation of motion in basics. Then you will understand about the graphs in very, very detail. Right? So, just without missing any point, prepare for your today's assignment right now. All the very best.